In the following example, we're asked to integrate sine squared of root x times cosine to the fifth of root x over root x. This example, first we should notice we have power of 5 and power of 2 for the sine and cosine functions. So direct u substitution with the trig functions is not going to work. Hopefully we can recognize by now that the argument here of root x, the derivative of the root x, is going to be 1 over root x dx. So by doing a u substitution, we can actually get rid of all the root x's. This is not a necessary step, but it will make the question a lot easier to look at, if nothing else. So if we say u is equal to root x, and du is equal to a half x to the minus half dx. Bringing the 2 over, then we end up with 2 du equals, we'll write it as 1 over root x dx. So here's our du, 1 over root x dx. These are u, and we stick a 2 outside. And so our integral that we're solving now is, we haven't changed it, but we've certainly made it look a lot easier. So 2 sine squared u times cosine to the fifth of u du. So it's an easier question to look at. Now we have sine squared cosine to the 5, so we have to remember our rules that state if we have an odd power of cosine, we have to factor out one of the cosines and change the rest to sine. So whichever is the odd power, remember that's what we're factoring out, and that's going to be the du for our later substitution. So we're going to keep the sine squared. We're going to keep one cosine with a du, and that's for a later substitution. The other 4 cosines, so cosine 4 is what we have left, are going to change. Remember, cosine squared is equal to 1 minus sine squared. That's u. And that has to be squared. I'm just going to fill in a little step in the middle here. Obviously the sine stayed, one of the cosines stayed here. We have cosine 4 left, which is actually cosine u squared all squared, and our substitution of cosine squared equals 1 minus sine squared is where that came from. So we don't actually write that, I'm just showing you where that came from, so let's pretend that's not there. So we have this. As soon as we replaced all the cosines, except for the one we've saved, now we can do another substitution. We're going to call this one t instead of u, because we've already used u. So t is going to equal sine. And the reason we saved the cosine is so we can take the derivative here and get cosine of u du. Substituting back over here now, integral of sine squared becomes t squared. 1 minus t squared all squared. And cosine u du is dt. Now we can expand and integrate. So this is 2 times the integral, expanding this bracket and multiplying by t. Maybe we'll do it in 2 steps. Keep the t, this becomes 1 minus 2t squared plus t to the 4 dt. And maybe we'll go ahead and integrate here now. So we have 2 out front. That gives us t squared, so that's t to the 3 over 3. Minus, that's going to be 2t to the 4, so we get 2t to the 5 over 5 when we integrate. That's going to be plus, that's t to the 6, so when we integrate it becomes t to the 7 over 7, and the whole thing is plus c. Now that's with t. We need with x, so for t we're going to put in sine u. For u we're going to put back root x, and that'll give us our final answer. So substituting them, we end up with 2 sine cubed of root x over 3 minus 4, 2 times 2, sine to the 5 root x over 5 plus 2 sine to the 7 root x over 7 plus a constant. And that'll be our final answer.